In this video, we are going to look at everything that you need to know for the topic of histograms for GCSE. Before we get into what a histogram actually is, we need to consider what is discrete data versus what is continuous data. So discrete data is quantitative information. So when we say quantitative, we're talking sort of numerical values, something that can be measured with numbers. That consists of distinct, countable, and often whole number values. Let's just concentrate on that final part just to think about something that would be considered discrete. So an example might be the number of people. Because when you're considering the number of people and measuring that, you'd use whole numbers. Okay, you could have 2 people, you could have 4 people, you could have 3 people, but you can't have 2.5 people, you can't have 2.75 people, for example. Okay, you can't have fractions of people. Therefore, it would be considered discrete. Now, you can have non-whole numbers in some scenarios. For example, shoe size. If you're buying shoes, well, one possible shoe size might be a 5, then you might have a 5.5, then you might have a 6. So clearly this isn't a whole number, but importantly, between the 5 and the 5.5, we don't have other values. We don't have 5.3 or 5.25 and so on. Okay, so shoe size would still be considered discrete, okay, because we can't have all those values between 2 data values. Now let's consider continuous. So it's also a type of quantitative information. Okay, so it's also going to be measured with numbers, and it can take any value within a given range. Okay, so that means it features an infinite number of potential measurements. Okay, and these can often be expressed as fractions or decimals. Now let's consider some examples. So I'm going to take height, which is the first one stated here. Well, you could be 146 centimeters tall. You could also be 147 centimeters tall. However, you could be 146.4 centimeters tall, you could be 146.435 centimeters tall, and so on. You can keep going to that extra degree of accuracy. Therefore, even between the 146 and the 147, there are an infinite number of possible heights because you can keep going to that extra decimal place. Hence why this is considered continuous. Now let's have a think about how we'd represent discrete data. So here we have a frequency table. And this is an example of discrete data, okay, because what we're measuring is the number of bedrooms, and the number of bedrooms can only be whole numbers, 1, 2, 3, 4. You can't have 1.23 of a bedroom, okay, so this will be discrete data. And we've got the frequencies for each of those possible options. Now, the logical representation for this frequency table here for our discrete data would be a bar chart, which you can see on the right here. So on my x-axis, we've got our data values for our bedrooms, R1, R2, R3, and R4. And importantly, you can't have anything between the 3 and 4. So we've got sort of blank space in there because you can't have 3.5 bedrooms. Then on my y-axis, we've got frequency. Okay, so that's these values here in the table. So the frequencies represent the height of my bars. So that is what we do with discrete data. Now let's consider continuous data instead. So now we have a frequency table consisting of continuous data, okay, because we've got ages. Now, in real life, we talk about ages as if they're discrete, like 15, 16, 17. However, you can be 15.43 years old, so age could be considered continuous. And importantly, also about this frequency table, there are unequal class widths. So what does that actually mean? The class width is the difference between the lower value and the upper value, okay, of our class. So this here in total is a class, so 15 to 20 is one of our classes. And then if we look at the lower bound and the upper bound, we have 15 and 20. So the class width is the difference between those two values. So if I was to do 20, subtract 15, well, that would give me 5. Okay, and that represents the difference between the two values and therefore the class width. So I am just going to note here that the class width is equal to 5. And if we look at our bottom class, so 20 to 50, the difference between 20 and 50 would be 30. So our class width this time would be equal to 30 instead. So you can see they've come out as different numbers, so we have unequal class widths. So what the data is telling us is that there are 15 people who are aged between 15 and 20 years, and there are the same number of people who are aged between 20 and 50 years. So let's try and draw a bar chart for this data. We have a couple of options as to how we could approach that. Okay, if I draw another axis over here, okay, we could put our frequency on our y-axis, and then on our x-axis, what we could do is just state our classes. Okay, we got 15 to 20. So down here, I might write 15 to 20. Okay, and then over here, somewhere on the right, I might write 20 to 50, which is my other class that I've got there. And then what you might try and do is draw a bar for each. Okay, so the height of the bar is the frequency. So for both of them, our frequencies are 15, so they're going to be the same height. So I might draw a bar going up to here, okay, like that, and we'll say that is a height of 15. Then we'll draw a bar of the same height like that, okay, and then it's at the same height, so we got 15 again. However, this wouldn't really make sense because of the unequal class widths, because this makes it seem like they're spread between the same number of ages. Okay, because 15 to 20 and 20 to 50, well, they're very different ranges in size. Okay, so we want to reflect that on my diagram. So let's take this other axis here, and what we're going to do is we're going to use the x-axis to represent the size of our class. Okay, so for our first class, we got 15 to 20. So what I'm going to do is I'm going to go to my x-axis, and I'm going to mark 15 here, and then identify 20, which is over here. So my bar is going to go from the 15 to the 20. So let's have a go at drawing it, and we know that the height is going to be the frequency, which is 15. So then use a ruler and pencil, which I'm not going to do, but you should. Okay, we're going to draw a line going up like this to the frequency of 15. We're then going to go across horizontally until we're above 20, okay, and then go down like that. And that would be my bar for my first class. Now let's do it for the second one. Okay, so we're going to do it for the 20 to 50. So what I'm going to start by doing is identifying 20 to 50 on the x-axis. So we've got 20 here. So the bar is going to start where the green one ends. Okay, because the classes touch each other. Okay, one sort of ends at 20, the other one starts at 20. And it's going to go up to 50. And we also know the frequency is 15, so that's going to be the height of my bar, which is the same height as the green one. So I would go along like this until I get above 50, and then we'll go down like that. Okay, and then that would be my bar chart drawn. But now let's have a think about whether this representation makes sense, because we now reflect the fact that we've got unequal class widths. However, the diagram makes it look like we have so many more people between 20 and 50 than we do have between 15 and 20, because that bar for 20 and 50 looks huge in comparison. And yet if we look at the data, the frequencies are exactly the same. So this representation doesn't make sense either. So we're going to have to consider a different approach. Okay, and this approach is going to involve trying to figure out, for example, between the 15 and 20, we have 15 people. Okay, so how many people are there per year? If the 15 people were distributed evenly between the 15 to 20 years of age, how many people would you get per year? Now, to figure that out, well, we know the class width is 5. There are 5 years between 15 and 20. So what I need to do is figure out how many people will there be in each of those 5 years if there are 15 people. So we need to split those 15 people up between those 5 years. So if you're splitting, you're doing division. Okay, so the calculation that I want to do here is going to be our frequency 15 divided by our class width, which is 5, which gives me an answer of 3. Okay, so that is going to be 3 people per year. Now let's do a similar calculation for our next class. So our frequency is 15, so that's going to be our numerator again. But this time we're splitting up our 15 people between 30 years, as that's our class width. So we'd do 15 divided by 30, and that would give 0.5 people per year. Now I accept we can't technically have 0.5 people, as discussed earlier. However, it's just an average, okay? That's what this calculation is representing. So in that scenario, it's okay to have decimals. What I'm now going to do is try and draw a different type of graph based off these values that we've obtained up here. Okay, so we got our data here. Now we got a slightly different axis, okay? Because we're no longer going to be using frequency on my y-axis. Okay, we're going to consider in a bit what we're going to name that y-axis, but currently we can refer to it as the people per year. Okay, those values are going to go on that y-axis. And of course, our data values, our ages, are still on our x-axis. So that hasn't changed, that has stayed the same. So if we consider my first bar here, it should be going from 15 to 20. Okay, so I'm going to identify 15, which is here, and then 20 is over here. Okay, so let's try and draw my bar, and the height of my bar is going to be 3, because we have 3 people per year in this class. Okay, so from 15, I'm going to go upwards until I hit 3, and then we're going to go across that height, and then down to the 20 on our x-axis like that. So that's my first bar drawn. Now let's do our second one. So for our second one, we're considering the 20 to 50. Okay, so we're starting at 20 this time, and we're ending at 50. And this time, the height of our bar is going to be the 0.5 people per year. Okay, so let's just identify 0.5 on my y-axis. And that's going to be the height of my bar. So starting from the 20, from where the other bar ended, we're going to go along like that, all the way to the end, and then down like that. Okay, and that would be my complete diagram. Now, this diagram I've drawn here is called a histogram. And the histogram shows the unequal class widths. It shows that we're going from 15 to 20 for the first one, and from 20 all the way to 50 for the next one. So that's represented. But also, if we look at the bars, it no longer looks like one of the bars is significantly bigger than the other one. In fact, it looks like they're the same size. And that would make sense, given that if we look at our frequencies, they're equal. Okay, so this is a better representation of my data. What we now just need to think about is what goes on my y-axis. What label am I going to put there? Because it's not frequency. Okay, the heights of the bars are not 15. It's our people per year. So our people per year can be referred to as frequency density. So frequency density is what you are going to be labeling your histogram y-axis. Okay, so please do not do frequency, as that's for your bar charts. Now, what we need to consider is, what is our formula for frequency density? How do we obtain these values? Well, I'm going to write frequency density over here. And this is the key formula for pretty much everything we're going to do in this video. This is going to be equal to, and let's consider our calculations that we did earlier to get our frequency densities. Okay, so over here, we got 15 divided by 5. Where did these numbers come from? Well, the 15 in particular, that was our frequency. So it seems that we're taking our frequency and we're going to divide. The question is, what have we divided by? Okay, where does the 5 come from in the denominator? Well, that is our class width. Okay, we're going to do the frequency divided by our class width, like that. So this is our key formula for our histogram questions. Now let's just consider a worded definition of frequency density. So at the bottom here, it says that frequency density is a statistical measure, okay, that represents the frequency per unit of data within a class interval. So if we relate that to what we've done here, our frequency in the question represents how many people we have. And then when it says per unit of data, well, if you look here, we got per year, okay, because our unit of data is years. So we're doing per year for our frequency density. And then my next question is, how is frequency represented on the diagram? We know frequency density is our y-axis, the height of our bars, but what about our frequency? Because our frequency is still important, okay, we still need to think about how that is on the diagram. So let's take our formula for frequency density over here, and let's rearrange it to make frequency the subject. So if I was going to do that, I need to multiply by the class width on both sides. So I'm going to write multiply by CW and multiply by CW just to represent that. So what we end up with is our frequency density multiplied by our class width. So I'm going to write that here. Frequency density multiplied by our class width. And that calculation is going to be equal to our frequency, which is what's left over on the right-hand side, like that. So now we've got a formula for frequency. However, what does this calculation actually represent on my diagram? Well, if we consider the green bar, our frequency density is essentially our height. So that's this here. And then our class width essentially represents the width of our bar down here. So we're doing the length of our bar or the height of our bar multiplied by our width of our bar. So what we're doing, because it's a rectangle, we're calculating the area of the bar. Therefore, frequency is equal to the area of the bars of our histogram. Which, if we look at our bars, well, the area of our two bars do look to be the same. Then if we look at our frequency table and look at our frequencies, well, they're the same. So that would make sense. Now, you can only assume that this key fact down here is true, assuming we know the correct scale on our frequency density axis. What you'll see later on is we will look at some problems where we're not given the scale on the frequency density axis. So then this key fact down here will just change a little bit. But for now, we're mainly going to be making use of the fact that the area of the bar is equal to the frequency. So in terms of when a histogram's essential, it's when you've got unequal class widths and often you have continuous data. Now, technically, you can draw it for other scenarios. You can draw a histogram for discrete data. And after all, actually, when you record ages, even though ages are technically continuous, you record the data as discrete because you often round to the nearest whole number. Okay, so it's fine to use it for discrete data as well if you want to. Now let's have a look at drawing a histogram from scratch. So we're now going to go through drawing a histogram when given a frequency table, and we're going to make use of our frequency density formula over here. So let's look at our data. We're given some ages, and we've got 5 classes in total, okay? We've got 5 rows in our table. Now, I do just want to discuss inequality symbols. Now, what you might notice is that for this 10 here, the inequality symbol next to it is not the same as 1, whereas for the 10 down here, the inequality symbol next to it is the same as. That ensures that the 10 is only included in one class. Okay, it will be included in the second one, but not the first one, because we don't want it appearing twice. Now, the general convention is that the same as inequality will be on the smaller number. So you can see for the 0 here, the 10 here, the 15 here, the 20 here, and the 30 here on the left, that's where the same as inequalities are consistently through the table. However, often in the final class, you might have a same as inequality on the upper value, okay, if you want to include the upper value in the data. Because if that was just y is smaller than 50, then that means anyone of 50 years of age wouldn't be included in the data. Now let's get started on the process of actually drawing our histogram. Now, if you're given a frequency table, make sure you add a frequency density column, because remember, frequency density is going to be our y-axis. So here we've got the column already, but you might have to add it in. And now let's make use of the formula in order to calculate our frequency densities. So for our first class, 0 to 10, our frequency is 5, and we're going to divide that by our class width, which is the difference between 0 and 10, so that's the difference of 10. So we have 5 divided by 10, which is 0.5. Now for our next class, our frequency is 16, and we're going to divide that by the difference between 10 and 15, so that's a difference of 5. So we have 16 over 5, which is 3.2. Then our next class has a frequency of 9, so we're going to do 9 divided by, and it's the difference between 15 and 20, which is a difference of 5. So that would give us 1.8. So for our next class, we have 14, so we're going to do 14 divided by the difference between 20 and 30, so that would be 10, and that equals to 1.4. And then finally, for our final class, we've got 4 as the frequency, and we're going to divide by the difference between 50 and 30, which is a difference of 20. So 4 over 20 is equal to 0.2. So now we've got all our frequency density values. Those values are going to be the heights of my bars. So let's have a go at actually drawing my histogram. So on my axis, we have frequency density on the y-axis, and then the x-axis are our data values, which in this case are years. So let's look at our first class, which is 0 to 10. So I'm going to identify 0 on my x-axis, which would be over here, 0. And then let's identify 10, which is over here. So that's going to be the width of my bar. The height of it is going to be 0.5. Okay, so you can see 0.5 is clearly indicated on my y-axis. Okay, so what I'm going to do is draw a horizontal line at that height. Okay, you should be using a pencil and ruler, which I'm not going to do here. But then once we've drawn across to 10, we're then going to go downwards like that. And that would be my first complete bar. Let's move on to the second one. So for our second one, it's going to be 10 to 15. Okay, so identify where 10 is, which is here. Okay, it's where the last bar ended. And then 15 would be halfway between the 10 and the 20. So that is going to be this point here. I will just note 15. Now the height of my bar should be 3.2. So let's just look at the scale on my axis. I believe there are 5 boxes taking me up to 1. Okay, so if we do 1 divided by 5, that gives me 0.2. So every box represents 0.2 on the frequency density axis. Okay, so if I want to go to 3.2, well, I need to go to 3, which is here, and then go 1 box higher. So this here would be 3.2. Okay, so my bar is going to go up to a height of that number that I marked there. So let's go upwards from this point here until we get to there. And then we're going to go across horizontally until we're over the 15, which is the end of my bar. And then we're going to go down like this, okay, to the bottom. And that will be my complete bar for 10 to 15. So let's move on to 15 to 20, which is my next class. So let's identify 15, which is here, and then 20, which is there. And then the height of my bar is going to be 1.8. Okay, so let's figure out where 1.8 is. Well, 2 is here. So if we go down one square, 1.8 should be there, okay, because each square is worth 0.2. Okay, so that's going to be the height of my bar. So it's going to start from 15 and it's going to be at that height until we get along to 20. And then we're going to go downwards like this. And that will be my bar for 15 to 20. Let's move on to our next class, which is 20 to 30. Okay, so let's identify 20 on my x-axis, which is here, and then 30, which is over here. And the height of my bar should be 1.4. Okay, so that's going to be 2 boxes above 1. So 1 is here, and then we're going to go 2 boxes higher. So 1.4 would be over here. Okay, so that's going to be the height of my bar. So we're going to go along at that height until we get above 30. And then we're going to go downwards like that. And that would be my complete bar. So let's move on to my final one, which is 30 to 50. Okay, so let's identify where 30 is, which is here. And then 50 is all the way at the end over here. And my frequency density this time is just 0.2. So that should be 1 box up on my y-axis. So that is going to be all the way down here. Now that's going to be the height of my bar. So I'm going to start my bar off at that height. And we're going to keep going along all the way to the end in this case. Okay, and then we're going to go down like this. And that would be my complete histogram. So just make sure you do it with a ruler and pencil. You don't need to color code your bars. That was just to make it a bit clearer. Now let's have a look at working in the opposite direction. If I gave you a histogram, would you be able to convert it back into a frequency table? So we've got our histogram here, which is about the height of some plants in a garden. And what we need to do is create the frequency table for this histogram. So I need to set up my table. Okay, so first I'm going to write my heights. I'm just going to state my unit, which is centimeters. And now let's write out our classes. So let's consider our bars. If we look at our first bar, it goes from 0 to 10. Okay, so what I'm going to write is I'm going to put a h in the middle to represent the heights, a 0 on the left as the smaller number, and then a 10 on the right as the bigger number. And then the h is going to be greater than 0. And the convention is that for the smaller number, we'll have a same as. And of course, the h will be smaller than 10, like that. So that's my first bar. Now let's look at our second one, which goes from the 10 to this point here, which I believe is the 15, the midpoint between 10 and 20. Okay, so my smaller number is 10. And then we're going to put the h in the middle. The bigger number is 15. And in terms of our inequality symbols, it'll be the same as those above. The h must be the same as or greater than 10, but it's got to be smaller than 15. So let's do our next bar. So that goes from the 15 to the 20. Okay, so let's put h in the middle. And the bigger number is 20, smaller number is 15. The inequality symbol should be the same. So same as and greater than pointing towards the h, and then a smaller than pointing towards the h. Then we got one more bar to do. Okay, so that starts at 20 and ends at 40. So put h in the middle, 40 to the right, the 20 to the left. And then the same as or greater than will be pointing towards the h when it comes to the 20. And then for the 40, well, previously we've just been doing smaller than symbols pointing towards the h. However, given that 40 is the biggest value, let's include it in the data. So I'm going to put a same as or less than pointing towards the h. So we've got our classes set up. We now need our frequency. Now remember, our histogram does not have frequency on the y-axis, it has frequency density. So I'm going to have to convert that back to the frequency. To do that, I'm going to make use of this formula here. The idea that the frequency is equal to the frequency density times the class width. So for each bar, we're going to have to do the frequency density times the class width. So let's consider my first bar, again, the height of it. So the height of it would be the 0.4. which is my frequency density, because each box on the y-axis represents 0.1. So I'm going to take that 0.4, and I'm going to multiply by the class width, so the difference between 0 and 10, which is 10, and that gives me my frequency, which is 4. Now let's consider my next bar. So my next one is a lot taller. Okay, it goes up to 2 on my frequency density scale. So I'm going to do 2 multiplied by the difference between the 10 and the 15, which is 5. Okay, so that gives me a frequency of 10. Now let's consider our third bar, which is even taller. Okay, it goes up to this height up here, which should be one box above 2.5, so that's going to be 2.6. So we need to do 2.6, our frequency density, times our class width, which is the difference between the 15 and the 20, so 5. And then 2.6 multiplied by 5 would be 13, which is our frequency. Then let's do our very final bar, okay, which is much closer to the bottom. And this bar, if we look at the height of it, okay, it's in the middle here. So one box is 0.1, two boxes is 0.2. The middle between them will be 0.15. Okay, so that's my frequency density. So we're going to do 0.15 multiplied by our class width, which is the difference between the 20 and the 40. So that's the difference of 20. So we're going to multiply by that. And then that would give me my final answer for the final frequency, which would be 3. And then we have ourselves a complete frequency table, which you could then utilize in many ways, such as estimating the mean or estimating the median and so on. Now let's have a look at completing a partially created histogram or table. So here's our question, and it says we've got an incomplete table and histogram, and it gives some information about the times in minutes that cars were parked in a car park. And we need to complete the table and the histogram. So let's look at the information we've been given. So in my histogram, we have 3 bars. We have this first bar here, the second one here, and this third one here. But if we look at our frequency table, we have 5 classes in total. 1, 2, 3, 4, 5. Therefore, there should be 5 bars on my histogram if it was fully complete. Now, in my frequency table, we seem to be missing a frequency here and a frequency here that we're going to have to determine. And then the other thing about this question to note is that we don't actually have a scale on our frequency density axis, okay, which is something we're going to have to determine to be able to draw our histogram. Now, in any histogram question, what you're going to want to do is to go to your frequency table and create another column for our frequency density. So I'm just going to write FD to indicate frequency density. And then what I would do next is go to any row in your table and, if it's possible, calculate the frequency density. Okay, so we're going to make use of this formula here, which is the frequency divided by the class width. So if we look at the first row in our table, because we don't have the frequency here, we can't calculate the frequency density. If we look at the next row, well, we got 35, and our class width is the difference between the 30 and the 40, so it's 10. So we can do 35 divided by 10, which gives me 3.5 for my frequency density. Now, my next row in my table, we don't have the frequency again, so we can't calculate the frequency density. In the row after that, we do have the complete information, so we could do the 30, the frequency, divided by our class width, which is the difference between 60 and 80, which is 20, so that comes out as 1.5. Then for my final row, our frequency is 20 this time, and then we're going to divide by our class width, which is the difference between 80 and 120, which is 40, so we get 0.5. Now, in order to obtain the other frequencies and frequency densities, we're going to have to consider our actual histogram, which is partially drawn on the left. But the issue is we don't currently know the frequency density scale. So let's have a think as to whether we can figure that out. Now, in order to be able to figure out the scale, we need to consider the 3 bars we've got. Okay, so it's for our first 3 classes, these 3 bars here. And do we have the actual frequency density value for any of those 3 classes? Well, if we look at the first 3 classes in our table, there's only one we have the actual frequency density for, which is the second one here, the 30 to 40, and our frequency density is 3.5. Therefore, I can go to the bar for 30 to 40, so that's going to be 30, which is here, to 40, which is here, and I know the height of this bar must be the 3.5. So I can label that on my diagram, so we would have 3.5 here, and now we can figure out the scale on my frequency density axis. Okay, if we zoom in, what we'll see is we have these little boxes, okay, but let's consider the bigger boxes, so like this, essentially 5 small boxes. Well, up to the 3.5, I believe we have one full big box, another full big box, a third one, a fourth one, a fifth one, a sixth one, and a 7th one. Okay, so 7 big boxes make 3.5. Therefore, the calculation that we want to do is 3.5 divided by 7, which gives me 0.5. So I know each big box is worth 0.5. So let's label that on my diagram, 0.5, then 1, then 1.5, then 2, this would be 2.5, and then this here would be 3, like that. So now we've got the full scale on my frequency density axis. So now let's consider which other bars can I get on my drawing. So if I zoom back out and look at my frequency table, let's consider which classes we have the frequency density for. Well, we've already considered a class 2, okay, and we know that bar is on the diagram, the 30 to 40. But the other two for which we have the frequency density would be class 4, the 60 to 80, and then class 5, the 80 to 120. So we can draw the bars for these classes. So let's consider the 60 to 80 then, okay, and we know that the frequency density for this is 1.5, therefore the height of the bar should be 1.5. So let's identify 60 on my histogram, so that's here, and 80 is over here, okay, and we need the height to be 1.5, okay, so 1.5 is clearly labelled on my axis, so what I can do is go to a height of 1.5 and draw across like this, and then down like this, okay, to get that bar complete. Now let's consider class 5, which is 80 to 120, and we know the frequency density is 0.5. So let's identify 80 on my x-axis, which is already marked there in red, and then 120 is the end there, okay, and the height of my bar is going to be the 0.5, okay, so 0.5 is clearly labelled on my y-axis, so I can go along at that height, okay, until the end of my histogram, which is over here at 120. And that would be my complete histogram drawn. We still haven't finished the question because we need to complete the frequency table, okay? We need to identify these frequency values. To do that, we have to make use of this formula down here, that the frequency is equal to the class width times the frequency density. So for our first class up here, let's do this one first, 0 to 30. Well, I know my class width is 30, okay, so it's going to be the frequency density times 30 is equal to my frequency. So to get my frequency density, I need to look at my histogram and find the bar for 0 to 30. So the bar for 0 to 30 would be 0 is here and then 30 is over here. So it's my very first bar, and hopefully you can see that the height of this bar is 1, so the frequency density is 1. So I am going to multiply by 1 over here. So 1 times 30 is equal to 30, which is my frequency. Now let's consider the 40 to 60. Okay, so let's identify the bar for 40 to 60. So that would be 40 to 60. And the height of my bar this time would be 3. Okay, so I am going to do my frequency density, which is 3, multiplied by my class width, which is the difference between 40 and 60, which is 20. And then the answer comes out as 60. Okay, so we have successfully completed our frequency table. Let's have a look at another question. So let's have a look at my question here. It says the histogram shows the information about the lifetime of some batteries. So you've got the diagram. Okay, it seems to be fully complete. We're not being given a frequency table this time. However, we also don't have the frequency density scale on the axis. So that's going to be something that maybe we're going to have to determine. But let's see what information and what the actual question is down here. So it says 2 of the batteries have a lifetime of between 1.5 years and 2.5 years. We need to find the total number of batteries. So when it says 2 of the batteries, this 2 here, that is a frequency. So they've given me a frequency. And it's specifically for 1.5 and 2.5 years between those two values. So let's go and identify where that bar is on my histogram. Well, 1.5 is over here, 2.5 is here. Therefore, it is this first bar in my histogram that they have given me the frequency for. Now, we need to find the total number of batteries, so we need to find the total frequency. Essentially, if we added up the frequency of all the classes, that's going to be my final answer. So I need to find the frequency of every single class. So to do that, I'm going to have to make use of this formula over here, the fact that the frequency is equal to the frequency density times the class width. So I require the class width for every single bar, which I have. We can read that off my x-axis. But we also need the frequency density for each bar, which we don't currently have because I don't have the scale on my frequency density axis. Now, to determine the scale on my frequency density axis, I need to see if I can find one frequency density. Well, we're going to be able to do that for a bit of information here about the 2 of the batteries having a lifetime between 1.5 and 2.5 years. Okay, because the 2 is a frequency. So if I go to my first formula for frequency density up here, okay, we've been given a frequency, which is 2, and then we need to divide by my class width to get the frequency density. So I'm going to write equals 2 and write FD to represent frequency density. Now, what is my class width of V1.5 to 2.5? Well, the difference between those values is 1. So I'm going to divide by 1. So the answer comes out as 2. Therefore, I know the height of my very first bar is 2. Okay, and 2, if we just take off this green part here, we can see is essentially what one big box represents. So if you do 5 little boxes up, you get one big box, and that is worth 2. So now I can fill in the full scale. We'd have 4, and then 6, and then 8, 10, 12. I don't think I need to go any higher than that. Okay, so we've obtained the frequency density scale. So now what I can go and do is try and determine the frequency of every single class. Okay, we know the frequency of the very first one. Okay, that was given in the question. It was V2. And then for my next bar, we're going to have to make use of this formula here. Okay, we're going to take the frequency density of this bar, which has a height of 6. Okay, so we're going to do 6. And we're going to multiply by our class width. So our class width is the difference between 2.5 and 3. So that would be 0.5. So that would be equal to 3. Okay, so that's my frequency for that bar. Now, if we do the next one, our frequency density is 12. That's the height of my bar. So we're going to do 12 times our class width, which is the difference between the 3 and the 3.5. So it's 0.5 again. And that gives me an answer of 6. So that's my next frequency. Now let's consider my next bar. Okay, so the height of my next bar here would be 8. Okay, so that is going to be my frequency density. And we're going to multiply by our class width, which is the difference between 3.5 and 4. So that is 0.5, which gives me an answer of 4. And then let's move on to my final bar. Okay, so the height of my final bar is here, which is at 4. So we're going to do 4 multiplied by our class width, which is the difference between 4 and 5, which is 1. So this is going to be equal to 4. So now I've got all my frequencies. We've got 2 for the first one, 3 for the next one, 6 for the next one, 4 for the next one, and 4 for the final one. To find the total number of batteries, which is what the question is asking for, I just have to add up all those black circled numbers. So I need to do 2 plus 3 plus 6 plus 4 plus 4. And that is going to give me a final answer of 19 batteries. So we're now going to use a histogram to estimate frequencies. So it says the histogram shows information about the times taken by a telephone call center to answer incoming calls. So we've got the complete histogram here, and you can see the frequency density scale is written there, so we don't need to go and find that. Now let's look at our question. It says work out the number of calls that are answered in 10 to 30 seconds. So when it says number of calls, that essentially means the frequency. They want us to calculate the frequency for 10 to 30 seconds. So let's go and identify that on my histogram. So where is 10 seconds? Well, that's halfway between 0 and 20. So that's going to be here. And then where is 30 seconds? Well, that's halfway between the 20 and the 40. So that is over here like that. So we need to calculate the frequency between those 2 points. Now, fortunately, between those 2 points, we have an entire bar. Okay, this entire bar represents 10 to 30. So we need to calculate the frequency of that bar. To do that, we need to make use of this formula over here. The frequency is equal to the frequency density times the class width. Okay, so let's try and find the frequency density. Well, the frequency density is the height of my bar, so that would be this point here. So that's 2 little squares above 2. So how much is a little square? Well, between 0 and 1, we seem to have 10 little squares. So therefore, each little square is 0.1. So this frequency density should be 2.2. So the frequency density for 10 to 30 seconds is 2.2. But we just need to know the class width and multiply by it. Well, the class width is the difference between the 10 and the 30, so that's 20. So if we do 2.2 multiplied by 20, we get 44, and that would be 44 calls. And that's my final answer to part A. Let's have a look at part B. So part B says work out an estimate for the number of calls that are answered in less than 40 seconds. Now this time we have the keyword estimate, which implies we can't calculate the actual frequency. We're only going to be able to obtain an estimate for it. So let's consider why. So let's go and identify where less than 40 seconds is on my x-axis. Well, 40 seconds is marked over here. We want less than that. So we want everything to the left. So what I'm going to do is draw a vertical line going upwards here. And the idea is we want everything within our bars to the left of that green line I've drawn. Okay, so what is to the left of that? Well, we have this little section here within this bar from 30 to 60. We also have the entirety of this bar here. Now, we know the frequency of this bar. That is 44. We did that in the previous part. So I'm just going to write that in. And then we also need to know the frequency of my first bar here. Okay, so to answer this question, I would need to calculate the frequency of my first bar, my second bar, and then a fraction of my third bar. Okay, we need this fraction over here, and this is the reason we're estimating. I could calculate the frequency of the entire bar going from the 30 to the 60. However, I don't know specifically how these calls are distributed within that bar. They might all be between the 50 and the 60. They might all be between the 40 and the 50. They might be partly between the 30 and the 40 and the 50 and the 60 and so on. So what I'm going to have to do is assume that these calls are distributed evenly between the 30 and the 60, and that's why we're estimating, because I don't actually know the correct distribution. So in order to answer this question, I need to obtain those frequencies mentioned. So let's go to my very first bar, okay, and calculate the frequency here. So for this bar, the frequency density would be, well, the height of the bar is up here, so that's going to be 3.1. So it's going to be our frequency density 3.1 multiplied by our class width, which is between 0 and 10. So that's a class width of 10. So that gives me a frequency of 31. Then for my second bar, I've got the frequency of 44. So I just need to figure out the red shaded region here. Now to do that, I first need to find the entire frequency for the whole bar going from 30 to 60. And then the idea is I need a fraction of that. And the fraction I would require is 1/3 of that. Because the 30 to the 40 is 1/3 of the entire bar. Okay, so let's calculate the frequency for the entire bar first. So for the entire bar, the height of our bar, our frequency density would be, I think, 0.9. So we're going to do 0.9 multiplied by the class width of the entire bar. So that's from 30 all the way to 60. So we're going to times by 30, which is the difference. So that would give me 27. And then specifically for my red shaded region, which I'm interested in, I want to take this 27 and I'm going to divide by 3 because I want 1/3 of my bar. Or in other words, we're going to multiply by 1/3. Okay, and that comes out as equal to 9. So that's the frequency of my red region. So therefore, to get my final answer to part B, I need to do all those circled numbers added together. So that would be the 31, which is the entire frequency of the first bar, plus the 44, which is the entire frequency of the second bar, and then plus the 9, which is 1/3 of the entire frequency of my third bar. So that's going to give me a final answer of 84 calls. Let's have a look at part C. So part C once again says work out an estimate for the number of calls, and it's those that are answered in more than 20 seconds, but less than 50 seconds. So let's go and identify 20 and 50 on my x-axis. Okay, so 20 is here, 50 is over here. So we want any calls between those two values. So I need to know the total frequency between 20 and 50. So what I'm going to do is I'm going to draw some vertical lines at 20 and 50. So let's go up like this at 20, okay, and then up like this at 50. Okay, and the idea is I want the frequency between those two green vertical lines. Now, there are no complete bars between these two vertical lines, so we can be sure we're going to be estimating here. Okay, we're going to be looking at fractions of bars, and we want half of my bar between 10 and 30, and then we also want 2/3 of my bar between 30 and 60. So let's start with the red shaded region, which is half of the bar between 10 and 30. So I know the total frequency between 20 and 30 is the 44 here. Well, what I have to do is divide the 44 by 2 because I want half of the bar, which is going to give me 22. Okay, so that's the frequency of the red shaded region in particular. Okay, so I will just annotate that here. And then now let's do my purple shaded region. So that is 2/3 of the bar of 30 to 60. Well, I've got the frequency for 30 to 60 here. It's the 27. Well, I want 2/3 of that. So I'm going to have to do 27 multiplied by 2/3, which is going to give me 18. Okay, so that is going to be the frequency of the purple shaded region. So I'm just going to annotate that on my diagram as well. So now we can give our answer to part C. Okay, it is going to be the 22 plus the 18, so my two circled purple numbers, and that is going to give me an answer of 40 calls. Let's have a look at one more question. Right, so we've got one more question here. We've got the same scenario. I've left the frequencies I have calculated on the diagram. It says work out an estimate for the number of calls that are answered in more than 65 seconds, but less than 83 seconds. So let's go to my diagram and figure out where's 65 and where's 83. Well, 65 is going to be halfway between 60 and 70, so 70 should be here. So therefore, 65 is going to be halfway, so it's going to be there. Then for 83, I think I want to figure out how much every little box on my x-axis represents. Well, we got 80 here, we got 90 here. Okay, so if we're considering 80 to 90, I believe we got 5 boxes in total. Okay, so that means every box is worth 2. So that means half a box is worth 1. So if I want 83, well, I'd go 1 box across from 80 and then a half box. Okay, so here would be 83. So the idea is if I draw vertical lines up at my 2 points, okay, I want the frequency between those 2 points. Now, clearly we're looking at a fraction of a bar again, hence why we're estimating. But this one might be a little bit trickier just to consider what fraction we actually want. Okay, so let's just figure out what fraction of the bar is contained between the 65 and the 83. Well, what you're going to do is consider the length of the whole bar. So the whole bar goes from 60 to 120. So 120 take away 60 would give me 60. So that's my length of my bar. Then let's consider the length between 65 and 83, the two numbers we are interested in the question. Well, the length between those is 83, subtract 65, so that is equal to 18. Okay, and the idea is the fraction of the entire bar between 65 and 83 would be the 18 out of the 60, which is the entire length of the bar. And that's given me the fraction that is between 65 and 83 in particular. So if I was to simplify that down, I believe that would be 3/10. So we want 3/10 of the frequency of the entire bar. So let's try and calculate the frequency of my entire bar. Well, if we use our formula over here, okay, we need to do frequency density multiplied by class width. Well, the class width is 60. We've already calculated that. Okay, when we were working with the 120, subtract 60 down here. We just need to know the height of my bar. So if I look at the height of this bar here, if we go across, I believe it's 0.3. So I need to do 0.3 multiplied by 60, and that gives me an answer of 18. So that 18 is the frequency of the entire bar, but remember, we only want 3/10 of that. So what we now need to do is 3/10 multiplied by 18, and that's going to give me a final answer for my estimation. So if I pop that into my calculator, I would get 5.4 calls. Now you can leave your answer like that, but sometimes what people do is they round it to the nearest integer. Okay, so we would get 5 calls to the nearest integer because we can't have a fraction of a call. Now let's move on to some of the hardest questions involving histograms. We're now going to look at a very challenging type of histogram question. Before we jump into it, I just want to talk about this formula down here for frequency. Okay, the idea that the frequency is equal to the frequency density times the class width. Well, if we consider one of the bars, remember the frequency density is essentially the height, so it's this length here. And then the class width would be this length down here. So when we're multiplying the frequency density by the class width, we are essentially finding the area of our bar. So the frequency is represented by the area of the bars. Now this is true providing we know the actual scale on the frequency density axis. If we don't know the actual scale on the frequency density axis, we will have to configure this key fact here. Let's have a read through the question. So it says the histogram shows how long people can hold their breath, and we are told that there are 54 people who could hold their breath for at least 1 minute. And then we need to work out how many could hold their breath for between 20 and 40 seconds. Well, let's start by considering where 20 and 40 seconds is on my histogram. So 20 is here and 40 is here. Therefore, I need to know the total frequency, which is how many people there are, okay, between the 40 and the 20. So as you can see, that involves the entirety of this bar here, as well as a fraction of this other bar here. Now, currently, we don't know the frequency density scale, so we can't jump in and start trying to calculate any frequencies yet. But let's consider the other bit of information given in the question, the fact that there were 54 people who could hold their breath for at least 1 minute. So 1 minute in seconds would be 60 seconds. So where's 60 seconds? That's over here. And let's say I was to draw a vertical line up at 60 like this. That means everything to the right of this represents 54 people. Therefore, the area of this here, as well as the area of this part here, represents 54 people. Now we want to figure out the frequency density scale. So to do that, ideally, we want to use this formula here, which is the frequency density is equal to the frequency over the class width. So essentially what we need to look for is, do we have a bar where we know both the frequency and the class width? Because that's what we've done previously to find the frequency density. Unfortunately, we don't have that information. Because if you consider the 54 people that could hold their breath for at least 1 minute, you can see that area I have shaded involves multiple bars. Therefore, that 54 is not a frequency for a specific bar, so we can't use that in the formula for frequency density. So once we've recognized that, we've essentially identified one of the harder type of histogram questions that you can get. And in order to answer this question, we need to make use of this key fact here, that the area of the bars represents the frequency. However, as I said, that's only true if we know the frequency density scale. In this question, we do not know the scale. So what we could do is make up our own scale. So what I could go and say is that every little box is worth 1. So therefore, every big box, so that's 5 little boxes, we could say is worth 5. So 5, 10, 15, 20, 25, 30, 35, and then 40. So now we've got numbers on our frequency density scale, and of course we know what the class widths are. Okay, they're written along the bottom on our x-axis, so we could jump in and start calculating areas. However, remember, I have made this scale up. This is most probably not going to be the correct scale. So therefore, we cannot claim that the area of the bars is exactly equal to the frequency. We're going to have to edit this key fact. Now, how we're going to modify it is that we are going to say that the frequency is proportional to the area of the bars. So why can we say it's proportional instead of equal to? Well, my frequency density scale that I've made up here is going to be some multiple of the actual frequency density scale. Because I said every little box is 1, but every little box might be 4, for example, or it might be 10. There's always going to be a direct multiplier between 1 and whatever other value the actual scale is. So essentially what I've gone and done is I've gone to the frequency density and I've multiplied by some value which we're going to call k. Now if we multiply the frequency density by k, we've essentially multiplied this entire calculation by k. So therefore, in turn, we have multiplied the frequency by k. So therefore, the result of using this formula will be proportional to the frequency. And remember, that formula is equivalent to the area of the bars. So the area of the bars is proportional to the frequency. Now let's have a think about how we can actually use this key fact to answer the question. So if we look back at the numerical bit of information given in the question, we know 54 people could hold their breath for at least 1 minute. So therefore, the area to the right of the 60 seconds, which is 1 minute, so this area here that I shaded, that should be proportional to the frequency. So that should be proportional to 54. So what I'm going to do is calculate the area of the red shaded region and the black shaded region. In order to do that, we're going to use my made up frequency density scale. Now, in terms of what you could do on the x-axis, well, you could either use the scale they've given to you. So if 60's here and then 80's over here, we know that 20 is represented by 10 boxes in total going along. So therefore, each little box going to the right is 2. However, what you could do is treat every little box going to the right as 1 if you wanted to, because essentially you're multiplying the class widths all by the same value. So once again, the frequency will still be proportional to the area. So what I'm going to do is treat every little box to the right as 1 as well. So essentially, when I'm calculating the area of my bars, if we're treating 1 to the right as 1 and 1 up as 1, we're essentially just working out how many little squares are in that shaded region that I have got there. So let's go through and calculate how many little squares I have in there then. So let's start with the red shaded region. So let's figure out how many little squares we have going to the right. So we have 5 along the bottom. Okay, and let's figure out how much we have going upwards. So I believe we have 3 big boxes. Each big box is worth 5. Okay, so we got 15 going upwards. So to calculate the area here, I would be doing the 5 multiplied by the 15, which gives me 75 squares. Okay, so what we've established is there's 75 little squares in that red shaded region. Now let's do the other part, which is greater than 60 seconds. So I'm going to shade that in red now. I want to work out how many little boxes are in there. So if we consider first along the bottom, okay, along the bottom we have 3 big boxes, so therefore we would have 15 going along the bottom. And then going upwards, we've got 4 little boxes. So therefore, to calculate the area, we are going to do 15 multiplied by 4, which gives me 60 little boxes or little squares. So now I can calculate how many little squares there are in total, greater than 60 seconds. So that is the 75 plus the 60. Okay, so I am going to do 75 plus 60, and that's going to give me 135 squares. So the idea is this 135 squares represents 54 people. So let's write that out. So we have 135 squares is equivalent to, so I'm going to write it as a ratio, 54 people. Now that bit of information on its own isn't massively useful. However, what we could do from this is determine how many squares represents one person. Because if I know how much represents one person, I've essentially got a key for my histogram. So to get that, I need to divide by 54 on both sides of my ratio. So then I'm going to get one person on the right-hand side, which is what I'm trying to find. And to figure out how many squares represents them, I need to do 135 divided by 54. And that gives me an answer of 2.5 squares. Therefore, every 2.5 little squares on my histogram represents one person. Now let's have a go at actually answering the question. So we need to work out how many could hold their breath for between 20 and 40 seconds. Now we've already located 20 and 40 on my x-axis. Now what I need to determine is between those 2 points, so if we draw 2 vertical lines going upwards, how many little squares do I have in there? So let's start with this full bar here. So let's figure out how much we go across. So we're going across 5 along the bottom. And then let's figure out how much we are going upwards, which is just equivalent to my frequency density scale. So going upwards, I believe that is 37. So if I want to calculate the area of this bar in terms of the little squares, I would be doing 5 multiplied by 37, which gives me 185 squares. Now let's do the same for the other part between 20 and 40 seconds. Okay, so we've got to move into the next bar, and it's going to be this part here specifically I need to calculate the area of. So along the bottom, we're going along 5 again, and this time going upwards, our frequency density is going to be 20. So therefore, to calculate the area of this part, we're doing 5 multiplied by 20, which gives me 100 squares. So now we can figure out the total area between 20 and 40, okay, by adding up the 100 squares and 185 squares. So if we do 100 plus 185, we get 285 squares in total. And now we need to try and figure out how many people does that represent. Well, we know there's 2.5 squares for every person, so I need to figure out how many times can I get the 2.5 into 285. Well, if you're trying to fit one number into another, you're doing division. So 285 divided by 2.5 should give me my answer, which is 114 people. So that would be the final answer to the question. Let's look at another question where we're going to have to make use of this key fact that the frequency is proportional to the area. So here's our next question. It says the histogram shows information about the times in minutes that patients spent at a doctor's surgery on one day. And it says no patient spent more than 40 minutes at the surgery. Why is that significant? Well, if we look at the histogram, our final bar ends at 40. So that's them essentially telling you you've got the complete histogram. Now just note we don't have the frequency density scale. And then it says calculate the percentage of the patients who spent between 25 and 40 minutes. Now, we don't have the frequency density scale, so the question is, do we have the frequency of one of our bars so that we can use this formula up here and calculate the frequency density for it and then obtain the scale? Well, we don't. We've actually been given no numerical frequencies about anything, so therefore we're not going to be able to obtain our frequency density scale. Now, if we consider what the question is asking for, it wants a percentage. Now, in order to get a percentage, you first need a fraction. So we need to determine the fraction of the patients who spent between 25 and 40 minutes at the surgery. So our denominator is going to be the frequency of all patients, and then our numerator will specifically be the frequency of those who spent between 25 and 40 minutes. So the frequency of patients between 25 and 40 minutes. If I can figure out both of these frequencies, I've got my fraction, then we can convert it into a percentage by multiplying by 100. However, because we don't have the frequency density scale, we're not going to be able to obtain the actual frequencies. Therefore, we're going to have to make up our own scale and make use of this key fact here, that the frequency is proportional to the area of the bars. So what I'm going to do is adjust my fraction down here. Instead of writing frequency, I'm going to take that off from both the numerator and denominator. And what I need to do is consider the area. So I need the area of patients between 25 and 40 minutes. And I need the area of all patients. Okay, because remember, both of these are going to be proportional to the actual frequencies. So they're still going to provide me the accurate fraction I need to calculate the percentage of all patients who spent between 25 and 40 minutes at the surgery. So let's go and make up my scale on my frequency density axis. So I'm just going to call every little box 1. So the bigger boxes, which is 5 little boxes, would be 5. So we'd have 10, and then 15, and then going up like that, 20, 25, 30, and then 35, and I can stop there. So let's start with working out the area of all the patients. So I need to work out the area of the entire histogram. So I'm going to have to go through this bar by bar, or some bars, if they're the same height, we could potentially join them together. For example, the first 2 bars seem to be the same height, so they form a rectangle together, and actually it looks like they form a square. If I also treat one box across on the x-axis as 1, it means we're just counting up how many little boxes I have got in my histogram. Okay, so going across, it seems we have 10 little boxes, and then going upwards, our frequency density is also 10. So we're going to do 10 multiplied by 10, which is going to give me 100 for this first part here. So I'm just going to circle that. Now let's move on to my next bar. So let's figure out the width of this bar. So it's 5 little boxes across. And then going upwards on my frequency density axis, I believe we've got 8. So this time we're going to do 5 multiplied by 8, which is equal to 40. So let's move on to my next one, which is a much longer bar. So we're once again 5 along. Okay, and this time my height, my frequency density is 35. So therefore I need to do 35 multiplied by the 5 I had at the bottom, which is going to give me 175. Then moving on to my next bar, it looks like we have 5 across the bottom again. And this time our frequency density, if we go upwards, is, I believe, 19. Okay, so we've got 19 going upwards, so therefore we're going to do 5 multiplied by 19, and that's going to give me 95. Now our final 3 bars are all the same height, so we can essentially combine it into one rectangle when we're calculating this, just to speed things up. So we're going from this point all the way to the end, so I believe that's 15 little boxes along the bottom, and then going upwards, the height, I believe, is 6. So we are doing 15 multiplied by 6, which gives me 90. So now what I can do is add up all of those circled numbers to get the total area of my histogram. So our calculation for our area would be 100 plus 40 plus 175 plus 95 and then plus 90. And then we'll pop that in the calculator and we get 500 boxes in total. So that's my denominator sorted. Let's sort my numerator. So we need the area of patients between 25 and 40 minutes specifically. Okay, so where is 25 and where is 40? Let's just figure that out. So 40 is over here and 25 is halfway between 20 and 30. Okay, so that's there. So we're considering between those 2 points. So if we draw vertical lines going upwards like this, it's essentially this final 3 bars that we combined into one. So the area there is the 90. So I've got my numerator, which is going to be 90 boxes. So now I can calculate my fraction. Okay, this is going to be equal to 90 divided by 500. And once I've got my fraction, all I need to do with this to get my percentage is I need to multiply by 100. Which if I pop into the calculator, gives me 18% like that. So that would be the answer to the question. Now, just thinking about an alternative question where our working that we've done would still be very useful. If this said probability instead, then the probability would give that as a fraction. So that would be the 90 out of 500, which we could simplify down and get 9 over 50. Okay, so if we were asked a probability, that would be pretty easy to do based off my working. We're now going to look at estimating the mean using a histogram. So let's have a look at our question. So it says the histogram gives some information about the weights of some fish. And our histogram is there. Now we haven't been given the scale on the frequency density axis. And we haven't been given any numerical values about the frequencies of the fish or how many fish are above a certain weight or below a certain weight or between certain weights. So therefore, it's going to be impossible to calculate my actual frequency density scale in this question. And then we're asked to find an estimate for the mean weight of fish. Now, the reason it's an estimate is because if we take one of the bars, for example, the 600 to 1000 bar, we only know the fish in that bar weigh between 600 and 1000 grams. We don't know the specific weights of any of those fish whatsoever, so therefore it's unrealistic to find the actual value of the mean. We're just going to have to estimate. So now let's think about how we're actually going to estimate the mean. Well, we're going to need a formula. So the estimate of the mean is equal to, and we're going to do a sum. So the symbol that we use to represent sum is sigma. And we are going to sum the midpoints. And when I say midpoints, I mean the midpoints of our classes multiplied by the frequencies. And we're going to divide by the total frequency, so the sum of the frequencies. Hence why I'm going to use sigma there again. Now, the reason we're using the midpoints is because we don't know any of the specific weights of the fish. So for each class, we need to pick a value to represent them, and the midpoint makes most sense. And the reason we're going to multiply the midpoints by the frequency is, for example, if we take our 600 to 1000 bar, okay, if we're using our midpoint 800, we're assuming all the fish in that bar weigh 800. So if we're multiplying by the frequency, so the number of fish in the bar, then essentially what we're doing is working out the total weight of the fish in that bar. And to calculate the mean, you have to work out the sum of all your data values, which is essentially the total weights of our fish, and then divide by how many fish there are, which is the sum of the frequency. So let's start by identifying the midpoints of our classes. So if we go to our first bar, okay, this is between 200 and then the midpoint of 200 and 300 is 250. So that's 250 there. But we want the midpoint of the bar. So this point here is going to be 225. So I'll just annotate that on. That is 225. Now for my next bar, it's between 250 and 300. So our midpoint here is going to be 275. Then for my next bar, it's the midpoint between 300 and 400. So that's going to be 350. Then for the next one here, it's between 400 and this here is going to be 450. So our midpoint is going to be 425. For my next bar after that, in here, well, the start of the bar is 450. The end point is 600. If you want a calculation to calculate the midpoint, well, I'd have to do the 450 plus the 600 and then divide by 2. So I believe that will give me 525. So I'll just annotate that onto my diagram. Then for my final bar, the midpoint will be the 800, which is the middle between the 600 and the 1000. So we got the midpoints on there. Now we need to get the frequencies in order to be able to use our formula. Now the issue is, I haven't been given any frequencies in the question, and I also do not know my scale on my frequency density axis. Therefore, I cannot use this formula here or this formula here to calculate frequencies or figure out the frequency density axis. Instead, we're going to have to use the key fact below that, which is that the frequency is proportional to the area of the bars. So therefore, I'm going to use the area of the bars to represent our frequency. So to do this, we're going to have to set our own frequency density scale. So what I'm going to do is go to my frequency density axis, and we're going to assume every single box is worth 1. So that's 1, that's 2, that's 3, that's 4, that's 5, 6, 7, 8. And I shouldn't have to go any further than that. Now let's go and modify my formula, because we're not going to be using the frequencies. We said we're using the area because we don't know the actual frequency density scale. So I'm going to rub out the frequency and I'm going to replace it with area. And I'm going to rub out the frequency in the denominator and replace it with area as well. Now, why can we do this and still get the correct answer? Well, to get from our frequency to our area, we would have to multiply by some value k because they're proportional to each other. So therefore, essentially what I've done is I've gone to the calculation of my numerator and I've multiplied by k to turn my frequency into an area. And I've also done the same in my denominator. I've multiplied by k to turn my frequency into our area. So we multiplied the fraction in the numerator by k and the denominator by k. So therefore, this fraction is still equivalent to the fraction I had written out before, which involved a frequency. So therefore, we should still get the same answer. So let's actually go and calculate the area of our bars. So the frequency density is going to be the height of my bars, and we've got each box as 1. Now on my x-axis, we can either use the scale given, or once again, you could just define as going 1 to the right, like this. Okay, we could still define that as 1. Okay, that's perfectly acceptable. You'll get the same answer regardless of what you do. So let's just treat every box to the right as 1, and as then it's going to be a bit easier to calculate my area. So for my first bar, we have a height of 5, and we're going across 1. So therefore, my area is 5 multiplied by 1, which is just 5. Now, if we look at my next bar, once again, we're going 1 across. Okay, this time, though, the height is 4. So 4 times 1 is just 4. Now, if we consider my third bar, we're going across by 2 this time. And the height of the bar is at 3. Okay, so 2 times 3 gives me 6 as my area. And you can see, because I'm treating each box as 1 up being 1 and 1 across being 1, we're essentially just counting up how many boxes we have in our histogram. So if we look at our next one, we're going 1 along. Okay, and the height, well, we assume it's the midpoint, as that's the only way we're going to be able to answer the question. And that midpoint there is 7.5. So 1 times 7.5 gives me 7.5. Then for my next bar, we have 3 going along. And then our height, our frequency density, is going to be 2.5. So we'd be doing 3 multiplied by 2.5, which gives me 7.5 as my area. Now moving on to my final bar, where if we look at the height of it, it's going up half a box. So that's going to be 0.5. And it's going along in total 8 boxes. So therefore, we're going to do 8 times 0.5. And that gives me an area of 4, which I'm going to write there. So we've now got all our areas. So now let's have a go at making use of my formula for estimating the mean. So my mean estimate is going to be equal to the sum of the midpoints times the area. So let's start writing that out then. So for my first bar over here, my midpoints are in red, my area is in green. So we're going to do 225 multiplied by 5. And we're doing a sum, so we're going to write addition. And then for my next bar, we're going to have 275, my midpoint, multiplied by 4. Then for my next bar after that, we got 350 multiplied by 6, so plus 350 times 6. And then for my bar after that, we got 7.5 and 425. So we're going to add 425 multiplied by 7.5. Then moving on to my next bar, okay, we got 525 as our midpoint. And then we're going to multiply by area, which is 7.5. And then for my final bar, okay, we've got a midpoint of 800. And we're going to times by our area, which was 4. Okay, so that is my numerator of my formula complete. We now need to focus on the denominator, which is just the sum of the area. Okay, so that's just the sum of all of the green numbers. Okay, so we got 5 in the first bar, plus 4 in the second, plus 6 in the third, plus 7.5 in the next one, plus 7.5 again in the next one, and then we got 4 in the last one. And then this whole calculation here is going to give me my estimate of my mean. So let's put it in the calculator. And we get 430.9 to 1 decimal place. And it's about the weight in grams. So therefore, I'm going to put a G at the end to indicate grams. Now let's have a go at estimating the median. So we got the same histogram as before. And I've left the areas in green annotated on the bars as they're going to come in handy. Now we need to find an estimate for the median weight of fish. Now it's once again an estimate because I don't know the specific values of any of the weights of the fish. And the idea of the median is that if we were to line up all the fish in weight order, okay, we would want that middle fish, whatever its weight is, that's going to be our median. Now in order to start the process of finding the median, I need to write out the cumulative frequency. Now we don't know the actual frequencies here, okay, we're using the area to represent it. So essentially we're working out the cumulative area. Okay, so I'm going to create a row at the bottom called cumulative area. Now up until the end of my first class here, we have a total area of 5. Okay, so the first value in my cumulative area row is going to be 5. Then up until the end of my next class here, we've added in an additional 4 in the area. So therefore we need to do 5 plus 4, and that's going to give me a total area of 9 up until that point. I'm just going to put a comma in between and then a comma after. And then by the end of my next class here, okay, we've added in an extra 6 in area. So therefore our total area is going to be 15. Then up until the end of the next class here, we've added in another 7.5. So we add the 7.5 onto the 15. So that gives me 22.5. So that's my total area so far. And then up until the end of the next class here, we're adding in another 7.5. So 7.5 added onto the 22.5 would give me 30. And then for my final class, we're adding in another 4. So therefore, we're going to end up with 34 in total once we get to the end of my final bar, because we're adding 4 onto 30. So then we've got ourselves the total area of all of the bars, which is 34, and we have all the cumulative ones up until the end of each bar. Now the next thing we need to figure out is what is the median position. Okay, if I was to line up all my fish, okay, which position would be the middle one? Well, the formula we use for median position when estimating is n over 2. Okay, so median position is equal to n over 2, where n is the number of data values, or in other words, it's the total frequency. Now, of course, we don't have frequency in this question. We're using area to represent the frequency. So therefore, in my case, the total frequency is going to be the total area instead. So we need to do the total area, which is the 34, and we need to divide by 2. So 34 divided by 2 gives me 17. Okay, so therefore, the median position is the 17th fish when we line them up in weight order. So what we need to figure out now is when is the 17th fish added in. Okay, so let's go back to my very first bar and look at our cumulative area. So we've only got 5 up until the end of my first bar. So therefore the 17th one is not going to be in there. Then we've only got 9 up until the end of my second bar. So once again, 17 is bigger than 9. Okay, so we have to look at my next bar. We're up until the end of it. We have 15. But once again, 17 is bigger than that. So we still haven't got to the median. And then if we look at our next bar, we have 22.5, which is greater than 17. So therefore, we have added the median in, going from our third bar to our fourth bar. So therefore, the median is going to be between 400 and the end of this bar here, which is going to be 450. So our median weight is going to be somewhere between 400 grams and 450 grams. Now we've got to think about how we're actually going to find our specific value for our estimate. So what I'm going to do is draw a number line. But at the start of my number line, I'm going to have the lowest weight in my median class. So my median class is the one we've identified as having the median in it, which is the 400 to the 450 grams. So therefore 400 grams is my lowest weight. And then let's identify for the end of my number line, the highest weight, which is going to be the 450 grams. Because we said the median has to be between those two values. Now, they're the numbers I'm putting at the bottom of my number line. Now let's consider what we're going to write at the top. Okay, at the top, we're going to write our cumulative frequencies. I want to know the cumulative frequency up until 400 grams. So that's going to be everything I had before the bar at 400 grams starts. So that's going to be the total area up until the bar with 400 in it. So that is going to be 15, okay, because we have 15 up until 400. So what I'm going to do is I'm going to write 15 up here. And then we also want to figure out the frequency up until the 450 grams. So that's at the end of the bar with 400 and 450 in it. So therefore, that's going to be the 22.5 we have here. So I'm going to write that at the top here. Now the reason I've done this is because we assume, for the purpose of estimating, that the data is distributed evenly within a class. So if there's a frequency of 15 up until 400 grams, we assume that 15th fish would weigh 400 grams. And also, if there are 22.5 fish, I know we can't technically have 22.5 fish, but we're only estimating. Okay, but if we assume there's 22.5 up until 450 grams, well, we assume that 22.5 fish would be 450 grams in weight. Now we have to consider where our median position falls into all of this. So remember, our median position is the 17th position. Okay, so 17 is between the 15 and the 22.5. That's why we're using this class. And the 17 would be sort of roughly over here. Okay, so I've identified the position of my median. I now need to find the actual value of my median. Well, that's going to be the weight of fish at the same point down here. So I need to figure out which value specifically goes to here. Now, in order to do this, I have to consider what fraction of the way along is the 17th position within this class. Okay, so the class starts at the 15th position. What fraction is specifically between the 15 and the 17? So to calculate this, I have to consider the entire length. So going all the way from the 15 to the end at the 22.5. Okay, so the calculation I can do is 22.5, subtract 15, okay, and that gives me 7.5. And that's going to be the denominator of my fraction. Then I have to consider specifically how much of my class is between the 15 and the 17. Well, a difference between 15 and 17 is 2. So therefore, it's going to be 2 over 7.5 of the way along. So therefore, this red arrow here represents 2 over 7.5 of my entire class. And the idea is my median weight is also going to be the same fraction of the way along between the 400 grams, the lowest value in the class, and the 450 grams, the highest value in the class. So therefore, this fraction down here is also going to be 2 over 7.5. Now I need to specifically calculate what value this is. Now in order to do that, I'm going to take the lowest value in my class, so the 400, and I'm going to add on 2 over 7.5 lots of the difference between the 400 grams and the 450 grams, which is essentially the length of my class in grams. Okay, so the difference between 400 and 450 is 50, so I'm going to multiply by 50, because this calculation here is going to work out specifically how many grams are represented by this red arrow, and then we're going to add that onto 400 to get my estimate of the median. So let's put it in the calculator, and we get 413.3 grams, and that would be my estimate for my median.